In our energy management system, we're going to be using a very slowly changing sine wave to indicate the different periods of the peak usage. So at the bottom to 0.2 volts, we're going to use that as the low peak time. We're going to use from 0.2 to 0.9 as the medium peak, and from 0.9 up to the maximum, we're going to be using that as the high peak time. So there's going to be 3 peak times that are going to be involved. Now, for our demonstration purposes, we're going to set our function generator to 10 millihertz. This will give a very slowly changing sine wave over the period of time that we need to demonstrate our project working. As with the A to D and D to A lab, you'll find the connections will be to TP7 for the red connectors coming from the function generator, and also common grounds coming to the ground pin on the DE1 interface board. As far as other connections go, we're going to have to make sure that this RS-232 connector is connected to our DE1 board and also to your partner's board to make sure that the communication can happen between the two terminals. Now on the sine wave, you should see it saying low if it's below 0.2. Between 0.2 and 9, you should see NR for normal, and you should see high for any number above 0.9 volts. Now this will be continually changing as the rest of your code is running. So this is the very first thing that you should actually get working, is these different symbols like the underbar, just as a small 0, and the full 8 showing for the various levels of your peak. So for 0 again to 0.2 volts, you should see just the underbar, you should see the 0 here and the NR for normal, and when it goes back to high, you should see the full 8 with HI beside it. If that's working, that's one of the parts of your project that you've got working, then you can continue on with the other parts. Another part of the project is this is our master on-off switch. If it's in the off position, then what you'll find is if you turn any of these switches on, the LEDs above them, the red LEDs above them, will come on. Turning them on and off will turn on and off the LEDs, and this works like a normal room. So if you walk into a room, you turn on the switch, the light comes on, you shut off the switch, the light goes out. That's very, very normal, and that's basically how it's going to work with the energy management system shut off. Now these 3 switches here, this is going to be room 3, room 2, room 1, and these are the lights for those 3. Over here we also have motion detectors. This is the motion detector for room 3, room 2, room 1. And what happens when we first turn on the energy management system by flipping this switch high, what you typically do is you're going to have to walk into the room, which is going to include motion, and notice the 2 green LEDs coming on when I push this. And when I do this, you're going to find that if there's no more motion detected, 5 seconds after the last push button thing here where the green LEDs come on, if I let that go and wait 5 seconds, this light will go out. Now in typical applications, what you're going to find is that time will be a lot longer. It could be maybe a minute, 2 minutes, something like that, where there's no motion detected in the room, and the lights will go out. So if I press this again for another 5 seconds, if I continually push this within that 5 seconds, when I let it up the last time, then 5 seconds after I let it go, this light will go out. And so that's our energy management system. So if you forget to shut off the lights and you walk out, there's no motion detected, the light goes out. Now if I turn on these other switches, notice nothing happens until I press the motion detector for that room. So this is room 3, 2, and room 1. So if I do this, and then if I were to actually hold all 3 of these down at the same time, and then let them up in different order. Let's let this one up first, this one, I should see the lights going out in exactly the same order. And there we go. And that's how basically the management system works. Now even if I sense motion here and I shut off the light should still go out. Sense motion, light should go out. Sense motion here and shutting it off, it should go out. And this is basically how our monitoring system here should work. It's very, very simple. Now, The next thing that we're going to look at is the communication, but this is the hardest part to get working, is to make sure that no matter when you turn on these lights, the switches, if they're on, it should only turn on the equivalent lights if the motion detector has been triggered in that room. As soon as 5 seconds has passed from the last time you press the button, that's when the light should go out. And if you get this working, this is the toughest part really of the whole project. Next, let's take a look at the communication between the two boards. Now, one of the checkpoints that you have in your project is that you can be transmitting. This is the monitoring station here. The green TX LED should be flashing, indicating that periodically you're sending information. Now, as it shows in the project documentation, there's going to be 2 bytes sent. And those 2 bytes being sent, one will have an MSB of 0, one will have an MSB of 1. Now on your partner's board, the receiver board, you should see the red LED glowing, but not the green transmitter LED. Because this is receiving, the monitoring station is broadcasting, this is receiving, and it's going to display what it receives on our PC screen. So let's see what that looks like. Now on the PC screen, which is Hyperterminal here running, we should see the title Green Home Monitoring System. Now we should also see the status of the master on-off switch, and in this case we've shut off our green monitoring system. And over here our peak value should go low, then medium, then high. Now if you've turned the speed up above 10 millihertz, then you might miss some of the readings going from low to medium. You might miss the medium and just get the high in here. So there we go, there's medium and finally high. So make sure that you've set your function generator to generate 10 millihertz, because you may miss the medium here. Now as we work through this, you'll see a number of things. This is room 1, room 2, room 3. This is the switch status right now. This is our motion detector over here. This is the status of our lights. And this is a cost meter associated with the different values for peak value here. So if the switch comes on and the lights go on and you're in high, you're going to get a cost of 3 for every time it sends information to the screen, whatever rate that you're sending information to the screen. If this is in the medium period of the peak value here, what it's going to do is it's going to add 2 to the cost counter for whatever light is on in whichever of your 3 rooms is here. So this will add 2 to the counter, as we'll see. And when you're in the low one, it's just going to add 1 to the cost counter here. And then the cost counter could be used later to multiply it by a certain number of kilowatt hours per whatever and generate an actual cost from the cost meter here. And what I'm going to do is I'm going to leave our master on-off switch off, and I'm just going to turn on the lights in the 3 rooms. And notice I just turn on the switches and the lights are on. There's no motion being detected here, and because this is in the low period, it's counting up in 1s, now it's counting up in 2s, and as soon as it gets to the medium to the high, in the high it's going to count up every 3. So notice these are all even. As soon as it goes to medium, it's going to go, and to high it's going to now count up in 3s. So that's what's going to happen here on the screen as we do this. Now if I happen to shut off one of the rooms, notice the counter stops here, and if I shut off the switch in the other ones, then that's what happens. And this is typical, that if you happen to leave a light on, and it's just going to keep using up more and more energy if you forget at the end of the day to shut off the light in that room. So this is exactly how this should work. Now I'm going to shut off all my switches here to shut off all my lights, with the status again being off, which means the energy management system is turned off. And notice what it says here, 1 to reset cost counter for room 1, 2, and 3. So I'm going to press on our PC keyboard 1, 2, and 3. And that should zero the counters again for some other measurements. Now the next thing I'm going to do is I'm going to turn on the energy management system. Right now I'm just turning on the master control switch, and it's turned on here. My switches right now are all off, but even if I turn on all 3 switches and they're on, the lights will be off unless there's motion detected, because at this point I haven't pressed any of the 3 push buttons which would indicate motion being detected. So right now we're in the medium, so if I push one button and let it go, it should say triggered. Even though I've let it go, 5 seconds after that the triggered light will go out here, and it's going to shut off the light and stop the count here. And that's basically what it should happen for all rooms. Now I've turned on, as you can see, all the switches. Let's push down all 3, and I'm going to let up the middle one, which is room 2, then room 3, then room 1. And it's going, even though I've let them go now, the triggered message will continue on until that 5 seconds has passed and lights go out and the count has stopped here. And basically that's your project. It's going to show you that every time you push a button when the light's on, and if I shut one of these 3 off, then it should clear the triggered system here, even though it was motion detected. All of these things are part and parcel of how your project should work. And again, pressing 1, 2, 3 on the PC keyboard should close these counts back to 0. So even if you were to turn on the system as it is here, even if you have the switches on and you've got motion on all 3, and you shut the switches off right away, it should shut all these off here, and the triggered messages should go out as well. And this is how your project should work, and this is how you're going to demonstrate that your project is working to your instructors, is to have both the sending and the receiving program working. And the trick here is, as I said, there's 2 bytes. So one of those bytes is going to have to send status of that's 1 bit for on and off. You've got 1 bit here for each of the switches for the room, 1 bit here for each of the lights that are here. You're also going to have another 3 bits here indicating motion detection. And this cost is going to be actually calculated right on this screen. It's not going to have any information coming in other than it already knows which switches are on and what the peak value is and how to count up. All that stuff is going to be done locally once it gets its information. So again, 1 bit, 2, 3, 4, 5, 6, 7, 8, 9, 10, and the peak value is going to take another 2 bits. That's 12 bits out of 14, or out of 16. So some of those, as I said, the MSB of one of those bytes is going to be 0, the MSB of the other one is going to be 1. So you can code up however you want to code your information, but you're going to have to send that information from the monitoring station to our system here, and be able to then display all that stuff on our display. Now there's any number of different techniques you can use, but again, you got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 bits that you have to send to be able to have this screen put up. However you encode it, that's up to you. Just make sure that when you encode it, you can decode it at the other end and then have that display here. Anyway, good luck on your project, and it should be a lot of fun.